All right, once again, here we are. This is 4.1b, angular and linear velocity. There are 3 questions here. You should be able to do, actually, let's just do, yeah, we can do all 3 of these. So go ahead and do those. I'll give you a minute, and then I'll come back. Pause. Okay, here are the 3 answers. The work for the first one is right here. The second one is right there. And then the third one, obviously, is right here. All right, our goal today, students will be able to calculate linear and angular velocity. Linear velocity is the speed at which an object travels measured in distance divided by time. Consider the formula d is equal to rt, where d is distance, r is the rate, and t is time. The rate is essentially the linear velocity. Consider an object or person that moves in a circular manner, such as a person on a carousel, a person on a Ferris wheel, or a point on a CD. 2 speeds occur when circular motion is considered. The first one is called angular speed. This is the number of radians the object or person travels per unit of time. And then the second one is the linear speed, and it is, as stated above, some distance traveled per unit of time. There are a couple of formulas that we're going to use for these. This first one, it's going to say W, and it's more of a Greek W, is equal to, this is radians over time, and this is omega when we talk about letters. And then the second one, velocity, this is V is equal to S over T. Or we could say that it is R angle measure over T, because S is really just R, the radius times the angle measure. We already talked about that. Or we can say it is D over T. So, some distance per unit of time. So those are the 3 that go along with this one, and then this one is this equation. So let's talk about this. Emma and Cora are riding on a carousel in San Francisco. Emma is somewhat cautious and wants to ride near the center, 8 feet from the center. So here is, excuse me, 8 feet. And then Cora would rather sit near the edge 18 feet from the center. So she is sitting, if we go along that same line, way out here. So this whole thing is 18 feet. And it would be everything from here to here. The carousel is rotating at 2.5 revolutions per minute. They want you to find the angular speed for Cora and then the linear speed. Now, we have to think about this in terms of 2 different speeds and what the difference is. If we're talking angular speed, hopefully it makes sense to you guys. It doesn't matter if you're sitting at this 8-foot mark or at this 18-foot mark. In terms of angle measure, you are traveling the same distance around the circle. It doesn't matter. Your angular speed will be exactly the same. Hopefully you guys see that, because it doesn't matter where you're sitting, the angle at which you're sitting. If I end up being somewhere, let's say, let's find one. Maybe I'm going this way. So all of a sudden we're both over here. Well, here's one of them. Here's the other one. The angle at which you are traveling is the same for both. That has not changed. So when you talk angular speed, you're talking basically, it doesn't matter where you are still traveling that same speed. Hopefully that makes sense to you guys. Let's go up here. Let me find a better pen than this one. Okay. So angular speed is going to be the same for both of these individuals. So we're talking the W here. And this is going to be, it said it was 2.5 revolutions per minute. 2.5 revs per 1 minute. And we're going to multiply this by. And we have to think about this in terms of the circle. Well, in a circle, you're going to travel 2 pi radians per 1 revolution. Hopefully you guys see that. Which ends up being the following. 2 times 2.5 is 5. We're going to have 1 revolution here, 1 revolution here. Those go away. So we're going to end up with 5 pi radians, and we're just going to say rads, per minute, which is approximately 15.7 rads per minute. Now, they may ask you for the exact answer, or they may ask you for a decimal equivalent. That is both of these. They are the same. So hopefully we see that. For the second part of the question, they're saying find the linear speed for Emma and for Cora. Now, linear speed is different. The closer you are to the center, the slower you're actually traveling linear speed-wise. And we kind of think about it like this. If you've ever been on a merry-go-round and you're hanging on to the end and somebody's spinning it super fast and then you let go, do you keep traveling in that arc? Well, you really don't. When you let go and jump off of the thing, you're going to travel linear, one speed, and it's going to be straight away from you, from the point where you released. So that's kind of what you got to think about here. Who's traveling faster? Well, the closer you are to the center, the slower you're going. The farther away you are, the faster you have to go. Linear speed. Hopefully we understand that. So for Emma, we will say the following. Linear speed. It's really going to be R times RW here, which means the radius, which in this case was 8 feet, and we're going to multiply that by 5 pi radians per minute. And we're going to get an answer here that's going to say 40 pi, and this is going to be feet per minute. Keep in mind radian, the word radian, it just simply means how many radiuses we laid down. There's no real piece for that. This would be equivalent to 125.7 feet per minute. So either of these two, depending on whether they want the exact answer or the decimal equivalent. For Cora, well, it's still R times the omega. And then this one, it would be 18 feet times 5 pi rads per minute. This one, 18 times that is going to be 90. So 90 feet. Sorry, not 90 feet. 90 pi. And this is in feet per minute. And this one is roughly equivalent to 282.7 feet per minute. That would be how fast the other person is traveling, Cora. So notice, closer we were to the center, the slower the travel rate was. Linear speed versus angular speed. Let's take a look at this next one. Next one says, Carson is riding on a Ferris wheel with a radius of 30 feet. The wheel is rotating at 1.5 revolutions per minute. Find the angular and linear speed in feet per minute of Carson's seat on the Ferris wheel. So, same idea applies here. First, we're going to find the angular speed. The angular speed, our angular speed here is going to be the following. It's going to be 1.5 revolutions per 1 minute. We have to multiply that by 2 pi radians per 1 revolution. Revolution cancels. we're going to get an answer here of 3 pi radians per minute, which is roughly 9.4 rads per min. So that would be the first part of the answer right here. And then the second part of the answer, they want to know what's the linear speed for this person. So our linear speed, we'd say velocity, or linear to velocity, or whatever you want to say. It's 30 feet, because that's the radius, times the actual angular speed of 3 pi radians per minute. That's going to give us an answer here of 90 pi feet per minute, which is approximately 282.7 feet per minute. That was the same answer we had in the last part. Hopefully we see that working, angular versus linear velocity. Example 3, no iPods in the 80s. Some of us are old enough to remember that. Consider old records. There were the large records called 33 1/3 and the small records called 45s. Find the angular velocity for each. So we're just looking for the angular velocity. That's not even looking right. Angular velocity here for each of these. So it is 33 1/3. Now what it means is 33 1/3 were because that's how many revolutions per minute it took for the record to go around per 1 minute. 45s, they're going around faster. So if you guys have seen your parents, if they still have an old record player, that's what the difference is. So we have this. We got to multiply it by 2 pi radians over 1 revolution. Revolutions cancel. We're going to end up with, we need to multiply this out. Keep in mind, 33 1/3 is really 100 over 3. We're multiplying that by 2 pi over 1, and we're saying this is in radians per minute. So this is going to be 200 pi over 3 rads per minute. Not rads, yeah, rads per minute. That's the angular velocity here, which is roughly 209.4 rads per minute. Now I'm doing both of these in both ways. I'm giving you the exact answer, and I'm giving you the decimal equivalent to 1 decimal place. That is something that you should do for right now. You should be doing that on your homework just so you get used to giving both answers so you know what you're looking for. Now the other one was saying 45, and this is revs per 1 minute, multiplying by 2 pi rads per 1 rev. Revs go away, we're going to be left with 90 pi rads per minute. This is roughly 282.7 again, rads per minute. Now, those are your answers for the 45s. So hopefully we see the difference here and how quickly one moves in relation to the other. The next part of this, degrees, minutes, and seconds. Surveyors measure angles in degrees, minutes, and seconds because they need very accurate measures. 60 minutes is 1 degree, 60 seconds is 1 minute, and 3,600 seconds would give you 1 degree. They want us to convert each of these to what they call degrees, minutes, seconds, DMS. Round to the nearest second. Now, the nice part when you're doing these, whatever your main number of your degree is, that's what the degree is going to be no matter if you are in degrees, minutes, seconds, or just degrees. So you don't need to calculate that part of it. That part should be fairly straightforward. I know in this problem that I'm going to have 23 degrees. That's going to be a non-factor here. What I do need to multiply is the 0.46 seconds, or 467. And I'm going to multiply that by 60. And the reason we're doing that is because to get my minute calculation, I have 3,600 seconds. So I'm going to have to multiply there. That gives me 28.02. Now, 28.02 tells me this right here is the minutes. So I can go back over here to my problem and say this is 28 minutes. Now I need the last part of this, degrees, minutes, and seconds. To find the seconds, I'm going to take what's left over here, 0.02, and I'm going to multiply that by 60. And that would give me the next part of my answer. Now we could do this a little quicker. I'm breaking this down just so you can see what happens. This is 1.2. This part right here is now the seconds. It said to the nearest second. They don't want a decimal here. So to the nearest second, this is going to say 1 second. That's what this answer would be. 23 degrees, 28 minutes, 1 second. Hopefully we see that. Okay, you try this next one. Example number 5, 47.58 degrees. I'll give you a minute. I'm pausing, so you should pause. All right, hopefully we came up with this answer. Just doing the same thing we did the problem before. So just plugging numbers in, multiplying them out. Converting each to decimal form. Now they want you to take degrees, minutes, seconds, and they want you to convert it to a decimal form, and they want you to round to 2 decimal places. So like I said before, this one says 34 degrees. That's not going to change. What does change is converting all of these back. So how do we do that? Well, we take the minutes, 17, but instead of multiplying here, we do the opposite. We divide. So 17 divided by 60. That's going to give you 0.28 and then a bunch of 3s. And then you need to take the other part of this thing, the seconds, 23, and you need to now divide by 3,600, because remember it's 60 and 60 again for minutes and then seconds, 3,600. That's going to give you an answer of 0.00638. And then you're going to take those two numbers and you're going to add them together. When you add these together, you're going to get 0.28, and then you have a 1 out here. This is going to be a 1. That makes a 7. 6 and 3 is 9. So you have 0.28971. They said to round this to 2 decimal places. So it's going to say 34.29 degrees. That is an approximation because obviously we are limited, but that is the answer we're looking for. Go ahead and work out this next one, and then I will come back. Pause and do it yourself. Okay, hopefully we see that that's the answer, 68.51 degrees, rounded to 2 decimal places. Like I said, pretty straightforward math. You just got to know when to multiply and when to divide and what you're multiplying and dividing by. The last part of this, just formulas that you should know to keep in mind. So, in order to find angular velocity, you simply multiply by, well, we multiplied by 2 pi radians over 1 revolution. The symbol that we use for angular velocity is that Greek W. This always represents radians per unit of time. We did everything in minutes, but obviously we could do this by hours. We just have to do a little more converting. In order to find linear velocity, use the formula V is equal to R times W. This always represents distance per unit of time. All right, hope you guys are getting comfortable with this idea. This is basically the first steps that we're going to take before we really jump into the trig portion of that, and that will come up in the next unit. Hopefully everybody's good. We'll see you in class. Have a great day.